Hello and welcome back to a little bit of chemistry practice. Last video we were talking about limiting and excess reactants or reagents. So today we're going to continue that lesson with a few more examples. Remember, limiting and excess reactants have a few different ways of solving them, but I'm showing you the method that I think is easier to understand and pick up, even if there are a few more steps. Let's go ahead and look at this first problem here. 1,000 grams of sodium chloride, so that's right here, is combined with 2,000 grams of barium phosphate. Balance the following equation and then find the limiting reactant. So there's 1,000 grams of this and there's 2,000 grams of this. Let's go ahead and balance this real fast. So we have PO4 here, but there's two phosphates over here, so we're probably going to have 2 right here. We can write 2Na3 PO4 plus BaCl, barium chloride. Barium phosphate, I have 6 sodiums and 6 chlorides right here. So let's put a 3 over here. And that might actually do it. Let's go ahead and look at this. We have 6 sodiums here, 6 here. We have 6 chlorines, 6 chlorines, and our phosphates and our barium, so we're good. Now, to find the limiting reactant, the easiest way is to do 2 mass-to-mass stoichiometry problems. Remember, if I have 1,000 grams of this sodium chloride and 2,000 grams of barium phosphate, they're going to combine together and create sodium phosphate and barium chloride. The problem is I might use up all 1,000 grams of sodium chloride and some of this and have some of my barium phosphate left over, or I might use up all 2,000 grams of barium phosphate and have some of my sodium chloride left over. I just don't know which one is the limiting reactant. The limiting reactant is the one that will use up all of the substance in the reaction. So what I'm going to do is do a mass-to-mass of sodium chloride, and I'll just pick one of these products. I'll say, you know what, if I use 1,000 grams of sodium chloride, how much barium chloride do I produce? Then I will do another mass-to-mass. I'll say, if I use 2,000 grams of barium phosphate, how much barium chloride do I produce? And then we can compare those numbers and get the limiting reactant. So let's start off. 1,000 grams of sodium chloride. I will convert it to moles. 1 mole of sodium chloride. I will find the molar mass of this with the periodic table, and it's about 58.44 grams of sodium chloride. I will now convert this to moles of barium chloride by looking at the mole ratio. So, make sure you use your balanced reaction, your balanced equation. I can't tell you how many times I've done this, and then I go back and I realize it wasn't balanced, and now you have to do the whole thing over again. 6 moles of sodium chloride are equal to about 3 moles of barium chloride. Now I will convert this to grams. 1 mole of barium chloride. And I will find my molar mass with the periodic table is 208.23 grams of barium chloride. I will do this math, and at the end I will get about 1,781.57 grams of barium chloride. Well, now I have to do this entire process over with barium phosphate. So I'll just put this number up here so we remember it. 1,781.57. And this is with sodium chloride. Get some space here. Let's go to 2,000 grams of barium phosphate. I will convert to moles. 1 mole of barium phosphate. Isn't this fun writing this whole thing out every time? Equals, I'll find the molar mass, 601.938 grams of barium phosphate. Now I would do my ratio. So 1 mole of barium phosphate equals about 3 moles of barium chloride. For some reason, I've noticed students have the biggest problem with this step here. It doesn't seem very intuitive to them. Really what you're doing is just going from grams to moles. Then we have to convert it from moles of barium phosphate to moles of barium chloride. That's what this step is. Okay, now we got to go back to grams. So 1 mole of barium chloride, and I will go find my molar mass is about 208 grams of barium chloride. And when I do this math, I'll get about 2,075 grams of barium chloride. Okay. So now we can compare these numbers. And what is this really telling me? If I use 1,000 grams of sodium chloride in this reaction, I will produce 1,781 grams of barium chloride. If I use 2,000 grams of barium phosphate, I will produce 2,075 grams of barium chloride. So really, what this is telling me is I'm going to use up all of my sodium chloride and most of my barium phosphate, and I will produce this much barium chloride. And the rest of my barium phosphate will be left over. It will be excess. And now I have to figure out how much excess I have. How many grams of excess reactant are left? So the answer to this first question is, what is the limiting reactant? It's sodium chloride. The amount of sodium will limit how much of my products I can make. So how do I find the excess reactant? I take this number right here, 1,000 grams of sodium chloride. Yet again, I got to convert it to moles. And I will go ahead and find my molar mass, 58.44 grams. And now, what I'm doing is I'm going to see if I use 1,000 grams of sodium chloride, how much barium phosphate is that going to take? So I need to do a ratio between sodium chloride, 6 moles, and barium phosphate, which is 1 mole. So it's a 1 to 6 ratio. 1 mole of barium phosphate. I will now take this back to grams. So 1 mole of barium phosphate equals about 601 grams. Of barium phosphate. So if I go ahead and do this math, what I'm going to find out is it will use about 1,716 grams of barium phosphate. Well, we have one final step to do. Let me go ahead and erase this so we have a little bit of room. Remember, I was given 2,000 grams of barium phosphate. I have now discovered that I'm only going to use 1,716 grams of barium phosphate. So if I take 2,000 grams, subtract 1,716, of course there's a little bit of extra in there, I'm going to get around 283 grams. Point. There were some decimals in there, but that's how much I have left over. So how many grams of excess reactant are left? I have 283 grams of barium phosphate left over if 1,000 grams of sodium chloride react with 2,000 grams of barium phosphate. So to recap really quick, we did 2 mass-to-mass stoichiometry equations. I then compared the output to one of my products. The one that produced the least amount of product was the limiting reactant. The other one was the excess. Then I had to go back and do another mass-to-mass to figure out the amount of excess reactant. Okay, let's go on to one more here. Methane, CH4. They just love to use methane in chemistry books and worksheets. That's all over the place. So you might as well just memorize that when you get a chance. Burns in oxygen to give carbon dioxide and water. So methane burns in oxygen to form carbon dioxide and water according to this following equation. If we have 0.250 moles of methane and it was burned in 1.25 moles of oxygen in a sealed steel vessel, what is the limiting reactant? Calculate the theoretical yield of water. Okay, let's go. Remember, we have 0.250 moles of this. So we'll start off with 0.250 moles of methane. I don't have to convert this to moles. It's already in moles, so I'll just go ahead and do my mole ratio. But before I do that, let's make sure this is actually balanced. I have carbon here, carbon, 2 oxygens. Actually, here there's 4 oxygen. There's 2 here and there's 2 here. There's 4 oxygen here, there's 4 hydrogen, so it's balanced. So, my ratio is 1 mole of CH4 to, I'll just pick water since that's what they're asking for, 2 moles of water. And they just want the theoretical yield in moles. Really, if I just did this calculation right here, I could get moles. But let me go to grams really fast so I can find out the limiting reactant. 1 mole of water is going to be about 18 grams molar mass. Okay, I do this math. I'll get about 9 grams of H2O, water. Okay, well, let's use 1.25 moles of oxygen of O2, and I'll do my mole ratio. So 2 moles of O2 equal 2 moles of H2O. Yet again, I go back to grams. 1 mole of H2O is about 18 grams of H2O. So I do this math, and I'll get about 22.5 grams of H2O. So I've discovered one thing. Methane is my limiting reactant. I can produce less water with methane than with my amount of oxygen. So I'm going to have some oxygen left over. But I don't have to have an excess reactant. All I have to do is calculate the theoretical yield in moles of water. That's really this answer right here. So I already have the answer, but it's in grams. So if I went back and just took out this step, I will have the answer in moles. 0.25 moles of CH4 times 2. And my answer is going to be 0.5 moles of water. Now, if that sort of confuses you, you could just take 9 grams and convert it back to moles. Okay? Remember that 1 mole of H2O is 18 grams. So I would have to say, okay, 1 mole of H2O is 18 grams. And then really what I'm doing is taking 9 divided by 18, and that would give me 0.5 of a mole. So half a mole is going to be produced. This equation is a little bit easier than the other one, but this confuses people because it gives you moles rather than grams, and for some reason I've noticed students are confused when that happens, even though it actually makes their life easier. But maybe they're just used to having mass-to-mass problems so often they forget that the moles to moles is easier. Okay, well, I hope that helps you. If you have any questions, let me know. And like I always say, the best way to learn this is practice, practice, practice.